Start. Okay, so last shape, properties of circle. Can somebody remind us what is a chord? Gavin.
A point from one circle to another that doesn't cross the center.
Alright, so not the best definition, but I get what you mean. Okay, so 2 points on a circle, and when you draw that line, it's a chord. How many chords can I have in a circle? Infinite, right? I can draw a line here, I can draw a chord here, I can draw a chord here, I can draw a chord here. Is my diameter a chord too?
Yeah.
Yes, right, because it's just one point to the other. So yeah, diameter is also considered a chord. Right bisector. Right, what's right bisector again? What's the definition of right bisector, Taden? Right in the middle. And what's the angle?
Possibly left.
Angle. Right bisector. So, William?
90.
Yeah, right angle. Okay. So, for example, this right here, okay, this red line is the right bisector of this chord. Where do you see it cross? Yep, the center. So this is actually a pretty interesting property, is that no matter where you draw a chord, your right bisector always goes through the center of the circle. Always, yeah. So if I draw a chord here and I draw a right bisector, it will go through the center. If I draw a chord here, I draw a right bisector, it will go through the center. Okay. They use this a lot in construction because it's also the closest distance. Okay, so keep that in mind whenever you see like a keyword with in a word problem. When you see like closest distance, that kind of thing, you know you're talking about right bisector. Okay, so example 1. you know me well now, Gavin. So example 1, show that the points K, L, and M lie on a circle with a center at 1 and 2. Hint, show that all 3 points are equal distance from the center. Alright, so let's plot this first. So -1, -2, 4. So Leandro, draw it on your graph too. Draw that circle. I need all of you to focus. Okay, and I want to show that this is the center. Okay. So I got 3 dots right here. Am I drawing a triangle? Absolutely not. What am I trying to draw? Circle. Okay. So is my circle gonna look like a rectangle like this, where those are the corners? Are there corners in a circle? No, right. So your circle, if these are points on your circle, yeah, it looks something like that. Because I've been drawing circles for for many years. Language, boys. What did you guys have for lunch? Like Andy, Jaden, you guys okay? You want to put away that? Okay, so if this is the center, how do I prove that that's the center? Yep.
Draw a triangle from the circle using the 3 points and then use the right bisector.
Okay, yeah, I could definitely do that. I could draw the chord and then the right bisector, but that's a lot of work. I want to do the easy way. What formula is that? Circle. Oh, the circle formula. Circle formula. Technically I could, but I still need something else. Like if I, okay, what's another way? Yep, Brian. No, centroid deals with median. So finding the centroid is not going to help in this case. Leandro, distance formula from the center to what? Why?
Find out like the equidistant from center.
Yeah, so it's actually right here. it's right here in the bracket. So if this is the center, which means these are all my radius. Okay, and so my radius is the same distance throughout my whole circle. Okay, so I need to use the distance formula. Okay, so to prove this, I need to show the radius is the same to all 3 points. And how do we do that? Distance formula. Okay. So that's the easiest way. So let's say the first one. I'm going to do from the center to point K. So distance between center to point K. Let's say, who should I ask? Rusvin, what is the formula for distance? Plus, minus, right. Minus x1. Good. Perfect. All right, don't make it your own formula because it doesn't work that way. So x2, -2 minus 1, and 4 minus 2. Okay, I'm using the points center to point K. So this to this. Okay. Who's good at mental math? Okay, Gavin. Oh, because I saw Gavin's hand up. Okay, Gavin, -2 minus 1.
Let me think. -3.
Okay, and then 4 minus 2. Okay, more mental math. -3 square plus 4. Yeah, so square root 13. Do I need to actually square root it?
No.
No, leave it as like this. Why? Because remember my point was not finding out how long that distance is. I just want to find out that all 3 are the same. Right. So then the second time I'm going to do the same thing. I'm going to check the distance between L and K. And then third, I'm going to check the distance between M and, oh, sorry, not M and K, M and L and C. L and C. Okay, L and C, M and C. And if this is all correct, what should everything equal to? Just 13? Just 13? Square root of 13. There is a big difference. And if it is, that means this, in fact, is the center. Okay. So just like that, you guys prove. You guys prove that a property in a circle. Okay. So let's move to the back. Yeah, for that one, that's all you do. You've already proved that. That's the center. Example 2. Verify that the center of the circle lies on the right bisector of xy. Okay. So this is my chord. I want to figure out if the center of the circle is on that right bisector. So again, right bisector means in the middle at 90 degrees. Right? So basically like that. We'll figure that out. We're gonna check. Okay. So this is the method that Jaden said. All right, the harder way. All right, and because it's the harder way, that's why I broke it in steps for you guys. Step 1, step 2, step 3, step 4. So first step is I want to find the midpoint of xy, because that's what the property of right bisector means. So midpoint formula, let's say Sedan, what is the midpoint formula? Yep. Good. Okay. So using the point x and y, -2 plus 5 divided by 2, and 5 plus 2 divided by 2. Oh, I use ugly numbers. So I get 3 over 2 and 7 over 2. All right. I don't want decimals. Let's keep it as a fraction. All right. Second step, I'm finding the slope of xy. So I'm finding the slope of this line. Slope formula. Rashan, slope formula. Slope formula.
Okay, what?
Slope formula? Y2.
Y2 minus Y1.
Yep.
And then X2 minus X1.
Yep. Okay. So when I do that, I get 2 minus 5. Yeah, sorry. The diagram is a little hard to see. And then 5 minus -2. Okay. And then I get -3 over 7. Okay. Now I don't want the slope of xy. I want the perpendicular slope. Okay, so Adam.
It'll be 7 over 2.
Right, positive or negative?
Positive.
Right, because this is negative, so negative reciprocal, 7 over 3. Okay, is this anything new? No, we know how to find the equation of the right bisector. Okay, so now let's find the equation. Y equals mx plus b. I'm going to use this slope. I'm going to use this midpoint. I'm going to sub it in here. So y is 7 over 2. M is 7 over 3. X is 3 over 2 plus b. Okay. Multiply this. So, 7. Okay, I'll write it the full way. So 21 over 6. Okay.
It's 0.
Yeah, it is. Don't spoil it. Well, technically, notice the 3 right here, they cancel out. Notice the 3 cancels out. So you could do this and then lowest common denominator, or right here, because the 3 cancel out, basically this is 7 over 2 as well. Okay. And then to solve for b, I move the numbers all to the other side. So 7 over 2 minus 7 over 2. What is that? 0. Okay. So therefore, what's the equation of the right bisector? Tayden, help me with this one.
So,
I have my M, I have my B. Yeah. Good. Right, because there's no B, or plus 0. Okay, so this is the equation of this red line right here. Okay. And then if any point, basically, any point on this red line if it's on the any point that is on this red line will satisfy that equation. So right here, I can sub in 0, 0 to verify that it is on the line. So left side, right side of my equation. Left side is y, right side of the equation is 7 over 3x. So when I sub in this 0, 0, y is 0, x is 0. What's 7 over 3 times 0?
0.
0, yeah. So what does that mean?
It is a
Yeah.
circle.
It is a circle, no. What did we just prove?
That the right bisector lies on the center
Uh,
of the circle.
okay, Andy, what were you gonna say? Andy, what were you gonna say?
Oh, I was gonna say on the center of the circle. The line passes through the center of the circle.
Okay, so
Yeah.
same thing as what William said. So the line passed through the center of the circle, which is at 0, 0. Or you can also say 0, 0, the center of the circle is on the right bisector. Both means the same thing. Okay, so you can see that my right bisector goes through this. Now let's say my circle is not in the middle. It's like somewhere over here. Then you do the exact same thing. You're just not subbing in 0, 0. You're just subbing in another coordinate. And then when you plug in left side, right side, it should give you the same.
So for these questions, we get the center of the circle, right? The coordinates.
Should I be nice?
Yeah.
Okay. Because if I don't give you the center, then what I would have to give you is another chord so that you can find the other right bisector, and then where the two right bisectors cross, that's your center of the circle. But that's a lot of work. uh, okay, 1 second. So there's the 2 examples for today. Any questions?
No, can I use the washroom?
Okay, wait. Okay, so 1, 4, and 5. So these questions right here, you don't have to do all of them. You could if you don't follow instructions. Okay, or if you want more practice. Otherwise, just do question 1, question 4, question 5. Why only the 3 questions? Because it's pretty repetitive. So you're just basically proving that the center is here, proving that the center is here, proving. Okay, so that's it. Answers are on the back for you to check. And that's all. Tomorrow we start review. Okay.
Why is he?